Okay, let's look at this first FP project. We'll launch it, and I'll turn off the sound. Okay, good. Let's take a look at this project. We'll launch it directly, and we'll launch it in standalone mode. We're not dealing with anything else yet. Actually, this is our single-player mode. Single-player mode means it's a single-player game. It won't create a dedicated server, nor will it connect to a dedicated server. The server can be created independently if you want to test it. And if you're doing a connection, then this thing is the editor. It will create a server and a client. What you need to note is this thing is equivalent to the host in the first player. This client and the host. Actually, it is both the client and the host. Then the subsequent players, they are just clients. They just need to connect to this host. This option means it will create a dedicated server. Then all other players created will only be clients. That's the situation. And here, based on the number of players, we only need to create one. We can take a look. This is a simple scene. This is a pure blueprint project. You should have no trouble looking at this project because you'll find it's relatively light on content. For example, this live opportunity is the level prototype. So these are some material parameters. This is its mesh. Static mesh. We call it a static skeletal mesh. Then it's a model. It's a model that cannot move because it has no skeleton. It is just a static mesh. And this texture is what we call a texture, as we often say. And then this material. So here there are three classes. As for these three classes, this F weapon. This is also some asset resources. Obviously, this is the weapon's asset resources. That is the model and sound effects with its material. Obviously, this material is a skeletal mesh. This one can play animations. This kind of skeletal mesh, it is purple. Right. That is basic blueprint knowledge. So this is a character model. You can see, it is also this kind of skeletal mesh. It can also play animations. This is its corresponding material. Also parameters, these are all some assets. And over here, this is the blueprint. So obviously, this is a level. Because it should have baked lighting. Probably not, so it will have such a file. After you build the lighting, related assets may generate this, and this is its input mapping. And of course, this part involves the mobile platform. Let's ignore the mobile platform for now. These are some assets related to enhanced input. Let's take a look first. We'll explain what this is later, and this area contains the relevant blueprints. This is the game mode, right? And this is the player controller. This is the projectile. This is the weapon. This is the weapon component. And this is the entire blueprint for this character. After we finish looking at this blueprint, let's launch it now. After we launch it, a character will be generated here. Let's press the semicolon key. We can enter the debut camera, then we can view the game from this three-dimensional perspective. After entering, we can move around freely. You can see there is actually a hand. Then we pick up this weapon. After picking it up, we can fire this projectile. You will notice this projectile. After it hits something, it will be destroyed. This is the same as what we made in a previous chapter, right? This is a projectile. Next, let's take a look inside this blueprint to see what it needs. First of all, we still look at its input mapping. So how do we respond to key presses? Look at this jump. This is defined as an input type. Its trigger mode is press and release. These are some parameters. This is the actions. Her time, right? It should be 0.5 seconds. And this is a Boolean value type. It is a Boolean value type. Because when you press the space bar, it feels like this. And this is look is a 2D. This is equivalent to when we move the mouse. It does this mapping. So this is a loop. And this move is also a 2D. Because we have up, down, left, right. So it's the up, down, left, right situation. You can see. And this is the short design. It is also Boolean. And it actually only has press. It doesn't have release. Because it triggers with a single click. This is the input action in the incremental input type. For this kind of thing. It defines the response for each type of input mapping. And then which specific keys they correspond to. It corresponds in this way. This is called the input mapping table. Sound color table. For this sound color table, you can see there are keys here. As for these keys, we first find the key. Once we have this key, then this thing corresponds to it. This input action corresponds to this thing. You can see we can see here. So it's equivalent to this mapping corresponds to the space bar, and this is a 2D mapping. And then they are WASD. No need to worry about WASD later. Then it corresponds to this mapping, and because it's a bidirectional mapping, so here there is a modifier. This modifier is negative, which means forward and backward are opposite. W is opposite, and because this is 2D, so you have an axis, you need to convert its axis. There is none here. There is only a negative here. So this is an input mapping table, an input mapping table. Okay, we won't worry about the other tablets. Then this is a weapon 1 because it makes a distinction. This is essentially the basic movement mapping. Basic movement mapping. If you want to change the table or the keys, this is an entry point. But this course probably won't cover changing tables or keys because that's not the focus of what we're teaching. Then these weapons actually means weapons. You see it corresponds to this input action. Its trigger method is left button, and you see there's nothing else. Okay, so this is a simple enhanced input mapping. Because if you want to use enhanced input mapping, so here in project setting here, there should be an input section. Let me check. And here you need the default player input class. You need to select the enhanced player input. Then the default input component class. You need to select the enhanced input component. Because enhanced input mapping is something after UE5. The most commonly used, like our previous action mapping and X mapping, or the key mapping and this directional mapping, we no longer use them because they are relatively outdated. Input action is recommended. Of course, it's not that they can't be used. It's just that this method, for doing something simple, it can be used that way. But when you work on a game project, if you use this, you'll need to wrap another layer on top of it with very complex logic. That would be very time consuming. So this thing, we will no longer use it. Okay, we will ignore this. This is related to mobile touchscreen. Some mobile pilot stuff. Ignore it. Then this file is finished. Let's mainly look at this blueprint. Since it is a pure blueprint project, we can see here in the order setting. This place uses this game mode. Generally, when we look at a level, we always start from the game mode because the game mode and the level are essentially ITL2U call art. Patents. This level blueprint, we generally don't write anything in it. Yes, generally we don't write anything, but we wrote a lot earlier, mainly to make it easier for everyone to learn and test. And here there is game mode. Then we can observe a bit more patiently. In this map section, here, in this place, you see it also specifies game mode. The hierarchy of this game mode is higher than that one. If you haven't specified it here, then it uses the one from project settings, and it specifies the editor startup map and the game's default map and its game instance. The game instance here, it is a default one. We don't need to worry about it either, because we often customize the game instance. Once you customize the game instance, remember to change it here. Okay, then we go into the game mode. You will find that the game mode is empty, because this kind is a blueprint class that only configures resources. This kind of blueprint represents this resource. It does not, after inheriting the parent class, it does not write any such logic. You only need to change the corresponding default values inside. So I changed this one thing. It changed the default player control to its own player control, and then changed this default point class to this before con class. So we can take a look at this game mod. Its logic inside should actually be empty. It only changed these two parameters. For things like this that have been modified, you can click it to restore it to default. Okay, next, let's first take a look at player control. Okay, as for player control, it is registered here, the enhanced input system we just mentioned, because you just bridged the gap. You only bridged. You took on this external mapping, but you haven't cut it through in the middle yet. Then drive the underlying layer. So this part belongs to a middle layer. At the start of the game, it obtains this enhanced input system's local player subsystem, and once it is obtained, then add an input mapping. So this is the priority. Obviously, high priority can override low priority. And here, use this mapping table, add it in. So that's the movement mapping. You might ask, what about the weapon mapping? When do we add it? Of course, we add it when picking up. So the player control, it only has this much written. This is a very clean, very tidy way of writing. Great. Then let's go back here. Now we can close this too. Now we need to look at this player character. With this way of writing, we can observe, first of all, it has an AR component here. Okay, this component points toward its forward direction, and it is. This thing should only exist under the editor. After packaging, this arrow should not be there. And this is its mesh. Nothing much to say about this. We already covered this mesh earlier. Over here, there might be some cloth-related things, but we don't care about those. Okay. And here, this mesh should be the capsule collider. And here there is a fast camera. This is relative to our camera. Then there are some small details here. This uses the controller to control rotation. There's nothing much to say about these things. Then here is its actual scalar mesh. As for this scalar mesh, it is still directly attached to the camera at this position. Specify here. It is a skeletal mesh, and specify here its animation blueprint. You can see, here is the animation blueprint. Okay, this thing. There's nothing much to say about this animation blueprint. We can take a look. Take a look at the state machine. This is not the main point we want to discuss. We simply don't care about these things. It's this kind of jump. The jump ends. We don't care about these things. This is an animation blueprint. You should have a general impression. This is knowledge within blueprint. I won't cover the. Okay, then. So what are we going to talk about? It's right here. There are 3 such events. Obviously, here is the loop we just corresponded to. Obviously, this loop is our rotating like this. So here, we directly call the interface on this pawn. We take the rotation of the mouse on the x and y axes and convert it into a vector. And input it directly. The interface here, we can't see it, so we'll ignore it. It's equivalent to here, directly calling the interface of the parent pawn. This controls the orientation of our character and makes our character's camera move along with it. And here is the movement. Movement is jot, W-A-H-T. So directly add this movement to our move. Add it as our movement input. Then here we definitely need to get the current orientation of our player. So this is added to his left and right. This is for forward and backward. That's a kind of orientation. So this part is an interface of the actor's parent class. This way, it's done. Movement in all 4 directions. And for jump, it also calls the character's interface. Because you know the character's class is pawn, then the pump's result is an actor. So such a desired relationship. Here when this mean this is the trigger, this is the start, this is when it completes. So it only needs to trigger such an interface at the start. And one complaining, this is a simple incremental input because these pins here are related to the type you selected. So that's how it is. Okay, this is all blueprint knowledge. So that concludes the character. Then let's take a look at this at the end. These are all very simple. We just need to look at this pickup. This actually feels a bit like something from a backpack. Inside the backpack pickup and also this valves component. So for the pickup, we can see it is a scalability. This scalability is actually something like this. A skeletal mesh. It should have no collision. You will notice. As for its collision, actually, the collision settings here are all set to block. Then it will overlap with this punch. And this is its collision box. We can take a look. Okay, this is its collision box. This collision box ignores everything and only overlaps with punk. When this punk overlaps, we can see there is an event here. This event has been overridden by him. So this event means when this collision occurs, we convert the collision class into our character class. If the conversion to this character class succeeds, then we continue forward. If it fails, it means the collision is not with a character. So if the character succeeds, first we cancel can this object collide the function. Then next, then we get its mesh. Then we get it. After getting this mesh, personal mesh, then find all its child components. This is done through reflection. Find all its child components, then iterate through all child components. This is done through reflection because, each of our components, when it is mounted onto the character, we can use reflection to get whether this object has a component. If this creature has a component here, then we won't loop here. By default, there is no component here. That means if we have a weapon, then we don't need to handle it. If it only has no weapon, only when it has no weapon, then we proceed. So what do? We add a weapon to it. So how do we add a weapon? Here we add a weapon component, add it to the trigger header. So it is added to this character. That is on the character. And as for this component, after adding it, then we remove this. Pick up from the world. So obviously this is an add component. It should be this interpretation, add component. Let me check. Obviously, you can see is this. It is this. It is this component added in. Then this component is added, then destroy itself because it has already been picked up. Actually, it's a very simple pickup item. Such a gameplay logic. This kind of logic is something we often use. This is not to verify repeated collisions. This is to verify whether this character has a weapon. Because sometimes we want this object to avoid repeated collisions. There will be such a situation. Okay. Then now let's go to our component. Go to our component. You will find this component is quite interesting. So first of all, when this component must be dynamically generated. After generation, its owner should be our character. This conversion must succeed here. After it succeeds, we will here essentially take our mesh. That is, we need to here add a component to the component. And then here, add this component to this socket. Obviously, there is a small pitfall here, because this inherits it from the static mesh component. So it is also a static mesh component. It is different from the one we are using. That is, we are directly using the static mesh component here, while it has been inherited once here. So it specifies this gun model at this location. Add this gun to this socket. Obviously, this socket is a flame. So you need to ensure that this skeletal mesh has this socket. Does this skeletal mesh's hand have this socket? Let's click in. You will find that this socket definitely exists. We can take a look. It should be, let's check. Let's search for it like this. It should be, remember, you can see here, there is a socket at this position. Then it can be added. Then we go back to this component. So this is equivalent to, it is a scalamacy component. We added on. These are some of its alignment rules, some options and such. Then here after we add the slot, we need to give it this ability. Remember this sentence. We give it this item. We need to grant it this ability. As for this ability, it will later extend into gas. We will keep emphasizing abilities to you. Abilities, okay. So here, we will have one that will. How do we grant ability? First, we get its player controller. After getting it, we get this local player subsystem. We register its input mappings, this priority, right? And here is its weapon. This input priority. After you finish registering it, then we update its animation blueprint. So obviously inside the animation blueprint, it will use different animation assets depending on whether it has a gun or not. Using things like animation sequences. Okay, once this part is done, let's take a look. So how do we correspond to this ability? When our left mouse button is pressed to trigger this input action, how is it triggered? First, it generates this particle effect. No, it's not really a particle effect. No, it generates a projectile. So this is its projectile. For the projectile, first we need to get the position of the AMO socket. What is RMO? Your first reaction must be the position of the muzzle. Let's go find it. It should be this. We found it inside cast default right here. You can see it's simple inside. Inside this IMO. You can see. So he definitely wants to spawn a projectile from this location. So here it simply does some calculations or some calculations based on the camera angle like this. This calculation is quite simple. This is a project offset, possibly a projectile spawner or something. Yeah. Then here it does a calculation. These are all knowledge of blueprint. After finishing, place this position, transform, set its rotation properly. After it's done, we will play a sound here. These are all presentation level things. For these things are logic. We usually write them using blueprint. Play a sound or write it using animation notifiers. After playing the sound, our gun here, it will have an animation. The gun can play this montage. You can see the gun shaking. This hand has an animation. This part plays the hand animation, no effect. Then we get this anim sequence. It plays the animation for the anim sequence. So the entire logic of this part has been fully explained to everyone. It's still quite simple. We only took about 10 minutes. Everyone can review it again. First, when our game starts, this actor is spawned based on the player class specified in the game mode. After spawning this game mode, in this player's player controller, we do input mapping like this. Such a responsive enhanced input mapping respectively completed the rotation of our mouse, but our current character uses this controller's rotation to control its rotation. And our animation blueprint is also activated, and the forward, backward, left, and right mappings are also activated. Next, we go to touch this pickup. Then this gun in the scene will disappear. And then a gun will be regenerated in our hand. These are both two models. these are two guns because we can see at this pickup location, it clearly drops a distorted, and then a component is generated in our hand. Weapon component. This component is inherited from the Google Mesh component. Then when we fire the gun, it will find the position of our gun muzzle and then generate a projectile at that location. This projectile will produce a projectile effect based on its gravity or initial velocity. This projectile effect is clearly set with a life cycle. However, we missed something. There is another projectile. Let's find this projectile. Obviously, this projectile has a height. When it collides, it has a height event. Then this height event must come from this clutch component. You can flip over here. It has if it's not this one, it should be this one. Let's take a look. If neither of these two is it, then it proves that this height event should be from itself. A height event on the actor itself. Yeah, okay. Then as for this height event, here, it goes set up a destroy. That is, if it hits something, it will apply a physical effect. That is, to the object that was hit, apply a physical force to it. Then, based on the impact point and position, apply the impact force. Then, after the impact, destroy itself. Of course, in this part, the other logic on the other side might be missing. But in reality, it should have a life cycle set here. We guess there should be a knife. Yes, meaning even if it doesn't hit an object, it will also be destroyed after 3 seconds. Okay, this is the logic for its collision object. Alright, that's it for this lesson. Because this is a case we worked on earlier. And now I want you to do everything in C++. You go ahead and write this thing from scratch. Let's see if you can do it. If I think you might still find it a bit difficult at the moment, then in the next lesson, I'll talk more about C++ with you. And after we finish that, don't look at the C++ code. Then you write everything entirely on your own. That is, how to write a game mode in C++, how to write a character, how to write the main component, how to write these blueprint logics, and convert them into C++ logic. If you can do that, then you should have a basic level of, because although we say converting blueprint to C++ logic is a very common task, whether in large or medium-sized companies, during early development, when doing demo validation, they all run on blueprints. Then later, when it matures, meaning the project is approved, and time to plan, time to iterate, then they start building this kind of C++ framework. So although this task is very simple, it is still very important. Alright, we should end this lesson here for everyone.